So what we're going to find out today is how we can use a real-life situation, and all the math that's going to come up in this situation, you could all do without matrices. Okay, but what we're going to find out is how would we use matrices to organize this data and be able to solve it. And this might be for computer programmers, this would be a nice way to store my information, to calculate things maybe a little bit faster, rather than how most businesses would probably do everything by hand. Okay, so the Burgess Sports Company supplies balls, bats, and gloves to different stores. So we've got store P, Q, R, and S, and how many balls, bats, and gloves that they've each ordered. Balls cost $8 each, bats $30 each, and the gloves $75 each. So this is an order that comes in, and we can write this total order as a matrix. And so what we'll do now, though, for our matrix is we'll put the numbers in, and I'm also going to add some labels just so I can sort of remember what things stood for. So this is P, Q, R, and S, and B, A for balls. This is good. I should have maybe sold something else. Balls, bats, and gloves could have had different letters. I should have called it lumber, bats, and gloves. Then you could. Well, sometimes they refer to the bat as lumber.
You said lumber bats.
Oh,
yeah.
Sorry. That's right. Balls, lumber, and gloves could have been used, but this will work out just fine. So our total order is a 4x3 matrix. And if we write the cost per item as a column matrix, we would get the following. A 3x1 matrix with balls, bats, and gloves as well. So this is just a setup, and later on you're going to find out why did I decide to write it as a column matrix instead of a row matrix. Because I could have made a matrix with the cost and the balls, bats, and gloves as a row matrix as well, but it's not going to work for the multiplication. So in this next step, we're going to use matrix multiplication, create a new matrix C depicting the total cost for each store. So I can take my order, which was a 4x3, and multiply it by my column matrix, which is my cost, which is a 3x1. And because the middle numbers here, because these middle numbers are the same, and not only are they the same, but they have to represent the same things in the same order. So you can really royally screw up matrix multiplication by writing things in the wrong order and get an answer that means absolutely nothing. Has no real life application whatsoever. So it's important that in the columns of the green matrix, I have balls, bats, and gloves, and in the rows of my cost matrix, I have balls, this was bats, and this was gloves. They have to match up. Then if we think about what our outside stood for, this 4 stood for P, Q, R, and S, and this 1 stood for cost. And so I get a new matrix, which now tells me the total cost that store P owes, the total cost that store Q is owing, R is owing, and S is owing all together. And if you think about how matrix multiplication works, this will make sense. Look at store P. I'll circle it here. This was their order. You take that row, turn it on its side, smash it into this one. They've ordered 70 bats. They each cost $80. They've ordered, balls. 30 balls. They each cost $30. And they've ordered 22 gloves. They each cost $75. Then you add them all up and you'll get your total owing for that store. So when we learnt matrix multiplication and we were wondering, why do we multiply and add? Well, here's a situation where you would want to do that. And whatever your outside dimensions were to begin with, they also tell you what your final matrix means. It's the store and the cost. So we can put all of those things together and we get totals for each one. Now, had I given you this information at the beginning, right? What grade is this? How much does store Q owe the Burgess Sports Company? Do you think that would be a grade 7 question? Do you think you could figure that out in? Grade 6 maybe? Maybe problem solving in grade, like, it's not a hard question, right? But what we're looking at now is how do we use a new construct, the idea of a matrix, and how does it work to calculate the same thing? And if you can store these things into a calculator, or you can store them in a computer program, perhaps it causes that computer program to calculate quicker. And a lot of stuff with computers is about efficiency, it's about speed, right? We're pretty spoiled. If we have to sit by a computer and the thing spins for 2 seconds, we get, oh, I think I need a new computer. I'm frustrated, like something's wrong. Or I need to go to another website because this one obviously isn't performing.
I remember when I used to wait 5 or 10 minutes for my computer to boot up, and now if it takes longer than a minute to boot up, I'm upset by that.
I have an old computer at home which up until last year, this last year I got a new one, but up until last year I did my taxes on, and I had to plug it in the morning so that it would be up and running a couple hours later. And last year the tax program said, if you try to use this next year, it will not work. We will not support this operating system anymore.
I'm the only person that's using the tax program.
Yeah.
Get off the computer.
Yeah. I happen to own some old computers that still work, and I am fairly patient,
You should be.
right? Because I teach you guys.
Company's like, I don't know if I can do this with Mr. JR. Like, he's the only one who needs it, but it is Mr. JR.
There you go.
Look at another one.
So how would you create a shipping matrix which includes a 2% shipping charge per item? So again, one of the nice things you can do in your calculator is maybe you put this in as matrix A and you put this in as matrix B. Then you could go to your calculator and do A times B and you get an answer. And you can store or save matrices as well. Do you want to see how to do that? You just push the store button, then you go to matrix and go down to C and store it as matrix C, and it puts all of those items into matrix C. So we'll try that for the next one for you guys. And then I can just take C and multiply it by 1.02, and this is a scalar multiplication. That will take all of these answers in C and add 2%. Is everybody okay with this idea of adding 2% by multiplying by 1.02? If you had 13%, you'd multiply by 1.13. Okay? Because all that is, basically it's based on the idea of 1 plus 0.02. The 1 is your original cost, and you're adding 2% more. And when you multiply that by C, well, there's your original cost, there's the amount that you would add. So you can just put it together and multiply all at once. Right? And that's why you can use 1.13 to figure out your total cost after taxes. Instead of finding out 13% first and adding it on, that does that both at the same time. What is the amount owed by each store? Well, then we've added our 2% shipping cost, and we have our total amounts. Yes? Oh. I'd switch too soon. What kind of program was I running?
The operating system.
Oh, it was Vista.
Oh, so that's actually later than when it was XP.
So, you're good? And then the last one, find the total amount owing to Burgess. If you wanted to, can you see that you could just take each of those things and add them up?
Yeah.
Can you figure out a matrix multiplication that would do that for you? Okay, you could just add them all up. Again, that wouldn't be bad. If you multiplied by the matrix 1, 1, 1, 1, which is a 1 by 4, it would turn and hit and add them all up. And you would get your final 1 by 1 answer. Of course, at this point, it's probably just easy to just add them all up. But that would work if you...
But if you had a program that did it, and that would be how you would
Faster, yeah, because you could add up a lot of
all
them.
you had to do was put that in
Yes,
instead of adding them up by hand.
then it could be quicker.
I'm sure the program would have a basic like.
Or a nice little for loop. No, this, yeah,
Why?
Hi, peeps.
we can do it.
Okay, so now one for you to try. You have to set it up. I won't put the answer up there yet. So what I did is I created, this is cheating by the way, but I put square brackets around that and made that matrix A. And I put square brackets around this and made it matrix B. A little bit of cheating. Okay? Now, the important thing here is to notice that this would be a 3 by 2 matrix, and with the dimensions underneath I wrote what things stood for. The 3 was well, sick, or carrier. The 2 was 11s and 12s. And here, the 2s is 11 and 12s, and the second 2 is males and females. That's important because then if I multiply A times B, not only do these two numbers in the middle have to match up with size, that they're both 2, they also have to match up with the same thing. They represent 11 and 12 in A and 11 and 12 in B. And if they do that, the answer that we'll get will be a 3 by 2, and the 3 will stand for the same thing the 3 stood for originally, well, sick, and carrier, and the 2 will stand for males and females. And now we have a whole array of answers that we can pull from. So yes, you could have solved this question, how many males are sick, directly by figuring it out with the numbers, but now we can just go to the green circle here of 79 and just say males sick, 79. So we can write it in. How many females are well? We can go to our matrix and the red circle right there. Females and well, 38, so we can write in 38. How many carriers are female? There's our blue circle, 76. And so with the matrix multiplication, each of these calculations would have had to been done separately to figure them out. Again, if you have technology that you can plug things in and multiply quickly, which we do in our calculators.
Why do you round up for the middle one but not round?
What were the decimals?
It was 30.
No, that's right.
Okay, 79.2.
70. I just rounded to the nearest. Yeah. Okay. Yeah, and I rounded up or down because it is hard to have half a sick person. Well, maybe you're just mostly sick, or kind of sick, or about to be sick. I rounded to the nearest number. Well, in this case,
I think you just round up.
it's the nearest number.
If you're a third sick, like you're sick.
You're third sick, you're sick. Almost sick.
So if you're a fraction of sick, then you're
Okay. Try the next one. Lots of information. You have to know how to read. All right, let's see We set up our first matrix given the information that we have. And then based on that, you're going to need to make a row matrix with the amount per day and how many numbers you need. Now, the reason I need to make that a row matrix is so that my beep that's here as a column matches up with my beep that's here as a row. Yeah, and if you flipped it, it's going to work out to the same numbers. So if you made your initial matrix A with beep across the top, then you would have to make a column matrix with beep going down, right? It sounds like this video is being edited for swearing. Enjoy it. Okay? And then if you multiply your 1 by 4 beep by your 4 by 4 beep, this is the beeping matrix you will get.
I did it back to swear word. Like the count video where everything was video with the count from Sesame Street.
Oh,
Oh, that was so good.
see?
I love
Wait, is that
and
2, 8,
they
10, the
just
first
bleep out the word count and it sounds so dirty.
2, 8, 10, yeah.
No, it's not weird. That's
Right?
yeah.
So,
Always multiplying.
how many are needed each day? Well, we have that in our previous answer.
Thank God it was a joke.
During August and September,
Whether you make that a column or a row.
those are your make money months, I guess. Production is increased by 40%. So you could take your per day and multiply it by 1.4, and now it tells you how much more per day you need of each one.
0.8 means that you have almost an entire.
Yeah, it's not quite finished, but the next day it'll finish up. And
Yeah, you get
in this sense, when you're producing something, I think a decimal is okay to keep. It just means it's not quite done. Yeah.
It's Windows ready.
Like Libby also like disagrees with
All right, part C. And now I'm going to set up a matrix for hours for producing different ones. Now, depending on how we set it up, I could set up my hours as a row matrix or as a column matrix. In this case, I'm going to have to set it up as a column matrix because my matrix B, which was how many I needed to produce per day, this beep has to match up with that beep, and then I get a 1 by 1 matrix which tells me how many hours per day are required.
Snap, you're wrong way. You're trying to use it.
2 B and C and 1 B after that, so that's the wrong way.
And then if I need 249 hours per day, and my workers work 7-hour days, I can divide 249 by 7, which comes out to 35.
0.5714.
35.57. So you could employ 35 or 36.
Employee 36, but because that's 36th person gets has to move early every day.
And then once you go to the 40% more, you could take your matrix D, which showed 40% more, and multiply it by E and get an answer for how many more. B, our matrix B right here was how many you needed per day, right? And then what we're using with that is we're looking at how many hours it takes to create those people hours. Okay.
Oh no, not okay.
Not okay.